So here you have the 2015 question 1 paper 2, and this is a question on probability. So the question says, a bank issues a unique 6-digit password to each of its online customers. The password may contain any of the numbers 0 to 9 in any position, and the numbers may be repeated. For example, the following is a valid password. So the important thing to take from that is the password is going to contain 6 numbers. And for each number, for each, say, option here, it can contain any of the numbers 0 to 9. So all the numbers from 0 to 9. So it can contain 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 10 possibilities. So there's 10 possibilities for this one, and because the numbers can be repeated, there's also going to be 10 possibilities for this one, and so on, because we can repeat the numbers as much as we like. So when we have in probability, when we're doing one thing and another thing, and means we multiply the probabilities. So we have 10 choices for the first one, and 10 choices for the second one, and. So it's going to be 10, so by itself 6 times, or we could say 10 to the power of 6. So 10 to the power of 6. So it's 10 to the power of 6. So we get 1 million. So that is going to be the total number of possible passwords. And then in part B, we're asked how many different passwords do not contain any 0. So we know a password contains has 6 numbers, but if it doesn't have any 0 and the numbers can be repeated, well then if we just can't include 0, well we're going to have 9 options left. So now we have 9 options, and because none of the digits can numbers in the password can contain a 0, so there's going to be 9 for all of them. So now our password is it's going to be 9 by itself 6 times, or you can say 9 to the power of 6, which is 531441. And then we're told that one password is selected at random from all the possible passwords. What is the probability that this password contains at least 1 0? So we know that all the possible passwords, the number of all possible passwords is 1 million. And the number of passwords with no 0 is 531441. So if we want to get the number of passwords that have at least 1 0, well, we can subtract the ones that contain no 0 from all the passwords. So at least 1 0. So it'll be it'll be 1, take 531441, and that gives us 468559. So this is the number of passwords that contain at least 1 0. So if we want to get the probability that we pick a password at random from all the possible passwords, so we want the number with at least 1 0, number with at least 1 0 over all passwords, the number of all passwords. So the number of passwords with at least 1 0 we got was this number here. So we'll put that here. And all the possible passwords we got was 1 million. So this goes underneath, and we just work this out on our calculator. So that gives us 0.468559. So I might round that to 0.469. So that's the probability that a password contains at least 1 0. So then the next we're told John is issued with one such password from the bank. Each time John wants to access his account online, the bank's website requires him to input 3 of his password digits into the boxes provided. So say 1, 2, 3, 4, 5, 6. So each time, so this is the diagram that they give us in the question, and how many different ways can the bank select the 3 boxes required? So he may be asked for the 2nd, the 4th, and the 5th box. So basically we have to see how many different ways can the bank actually just select the boxes for him to choose the possible passwords that they're going to ask him. So there are 2 different kind of ways that we can do this. We can actually write out all the different ways. If we wanted, we could say he could pick the 1st, the 2nd, and the 3rd. He could pick the bank could pick the 1st, the 2nd, and the 4th. The 1st, the 2nd, and the 5th, or the 1st, the 2nd, and the 6th, and all the different ways the bank could do this, and we could write that out. So I might actually just write that out. So we could do the 1st, the 2nd, and then we could do the 1st. We could do the 1st. Say if we put the 2 here in the middle, the 2nd, the 1st, and the 3rd. 1, 2, or the 1st, or we can, or say if we go with 1, keep 1 as our 1, 3, 4. We could go with 1, 3, 5, 1, 3, 6, and then we could go with 1, 4, 5, 1, 4, 6, and we could go with 1, 5, 6, and then we could go 2, 3, 4, 2, 3, 5, 2, 3, 6, 2, 4, 5, and then 2, 4, 6, and then 2, 5, 6, 3, 4, 5, 3, 4, 6, 3, 5, 6, and 4, 5, 6. So I'll just count how many. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 different ways that the bank could ask for the certain digits. Or when we have, say, 6 kind of options, and we are only going to choose 3 of them, that's a function on our calculator called choosing. It's called 6 choose 3. So we can write it as 6. So it'd be 6 kind of bracket 6 choose 3. So we have 6 options and we're choosing 3 of them. So it's usually with things or something that. So if we want to get that function on our calculator, it's going to be 6 and then shift and then the C button here and then 3, and we get 20. So we have 2 options of the way that we could answer that question.